Pull the station, please.
Pull the station.
Yeah, I don't know.
Kick the tires, lights.
Woo! Yep. Okay, get ready. Get ready. Breathing. I think you. Yep. Shut her down. Shut her down. Okay, let me know it's shut. Is it shut? Shut her down. Shut her down completely. Shut her down. Shut her down. Shut her down. Shut her down. All the way.
Yeah. Holy Jesus, they're gonna flood it right out.
Hang on, boys.
Hang on tight, guys. Hey, you wanted 8 feet originally. Guess what? You got it.
Yeah. All right. Okay.
Way to go, boys.
Nice. Turn it on.
Okay. All right. Yeah. All right. Looks pretty good. And that first minute, though, I'll tell you that first minute, it's like,
Yeah, I know.
fun the way it happens. All right. I'm going to go get my sample on that. Oh, no. All right, can we shut the bells off? Yeah. All right, good. Wow.
Fire sprinklers are highly effective active systems against fires. Over 96% of fires in buildings are controlled by fire sprinklers alone. They're affordable, effective and simple, which explains why every year over 40 million fire sprinkler heads are fitted in houses, factories and commercial buildings. In some countries these systems are mandatory in such places as hotels, factories, meeting places, schools and museums. Let's look at how they work. The essential components are a water supply system and a fire sprinkler head. The sprinkler head is made up of a plug, a liquid-filled glass bulb, a sprinkler and a frame. When a fire starts, the temperature of the environment rises and the liquid in the glass bulb begins to expand. If the temperature continues to rise, the liquid expands so much that it breaks the glass. There's then nothing left to stop the water and it begins to come out from the plug. When water hits the sprinkler, it's spread over a larger area. There are different types of glass bulb filled with different liquids, and these are color-coded. Orange bulbs have an operational temperature of 57 Celsius or 135 Fahrenheit. Red bulbs 68 Celsius, 155 Fahrenheit. Yellow bulbs 79 Celsius, 175 Fahrenheit. Green bulbs 93 Celsius, 200 Fahrenheit. Blue bulbs 141 Celsius, 286 Fahrenheit. Purple bulbs 182 Celsius, 360 Fahrenheit. And black bulbs 227 Celsius, 440 Fahrenheit. Fire sprinkler systems operate in different ways as well. The type we've just explained is known as a wet pipe system and is the commonest in use. Each sprinkler head is activated independently and the main goal is to reduce water damage in the event of a false alarm. Another type is the dry pipe system. In this, the pipes are filled with pressurized nitrogen which is released if a fire activates the valves in the sprinkler head. The pipes then fill with water, which is discharged over the smoke or flames. Dry pipe systems are widely used in cold climates since there's a high risk of frozen pipes, preventing an emergency fire response. Pre-action systems are a kind of dry pipe sprinkler system that require two activation steps. When heat or smoke is detected, the pre-action valve opens and allows water into the pipes. Then, the sprinkler heads can be individually activated to release water over the fire. This two-step process enables facilities to shut off the system in case of a false alarm, protecting assets from water damage. Pre-action systems are especially useful in places where accidental discharge could lead to irreparable damage, such as in museums, libraries and data centers. Another type of system is the deluge sprinkler system, which also uses dry pipe technology. However, in this system the sprinkler heads are always open. The sprinkler heads don't have heat sensing elements but instead are activated by external smoke or heat sensors. Once heat is detected, water fills the pipes and is released to all open sprinkler heads, creating a flooding effect across the entire area. This system is most often used in industries with flammable liquids, which pose the threat of rapidly spreading fire.
One of the most important components of a fire protection system is the automatic fire sprinklers. In general, a sprinkler is activated by the heat put off by the fire once it reaches a certain temperature at the ceiling around that particular head. A common misconception is that every sprinkler head in a system will go off at once after the first sprinkler has activated. While systems that behave somewhat like this exist, deluge-type systems, it is pretty uncommon and used in special situations like certain types of aircraft hangars. In most cases, the fire sprinklers that activate only do so around and over the fire. These systems are most effective in the fire's initial growth stage, as they work to spread a continuous flow of water over the fire, ideally dampening it enough to be fully put out. There are several types of fire sprinklers. Wet pipe sprinkler systems are filled with water at all times, allowing for quick fire suppression. They are the most common type of sprinkler and are both cost-efficient and low maintenance. Dry sprinkler systems use pressurized air in the pipe which exits before water escapes. Pre-action sprinkler systems are filled with air and water passes through if the smoke alarm or detector goes off. They are best used in locations looking to avoid accidental and unnecessary water damage such as libraries or data centers. Deluge sprinkler systems feature open nozzles and are common to industrial parks as they respond to hazards including flammable liquids spilling across a floor. Automatic fire sprinklers. Automatic fire sprinklers are installed during the initial construction of a building but can be updated in the case of a faulty system or in response to new codes regarding fire safety. When installing initially, the building's risk factors and layout are taken into consideration to ensure that safety is maximized regardless of the specific and unique challenges brought about from a building's design plan. Standpipes. Much like automatic fire sprinklers, standpipes are built into the initial construction of a building. They are installed in the stairways of buildings that exceed a certain height or size, but can sometimes be located throughout the walls of the entire structure, providing coverage on every floor. These standpipes provide water flow to hose valves, which, much like fire hydrants, firefighters can connect fire hoses to. Much like fire hydrants, firefighters can utilize this connection to spray water from the building's main water source from any floor they may need to. There are three classes of the standpipe. Class 1 systems 2-1/2 hose connections are provided for use by fire departments and those trained in handling heavy water streams. In high-rise buildings without sprinklers and beyond the reach of fire department ladders, Class 1 systems provide water supply for the primary means of fire fighting, i.e. manually. Class 2 systems 1-1/2 hose lines are provided for use by trained building occupants until the fire department arrives. Class 3 systems shall provide 1-1/2 38 mm hose stations to supply water for use by trained building occupants and 2-1/2 64 mm hose connections to supply a larger volume of water for use by fire departments and those trained in handling heavy water streams. Fire department connections. Fire department connections are utilized by the firefighters on the scene to either supply water to the standpipes or supplement the building's already existing water supply. This additional water can be sourced from the fire truck itself or from a hydrant that can tap into the water the building's standpipes may not have access to. These are usually included in the initial creation of the standpipes in order to provide an extra source of water to the building. Smoke control systems. Through the application of both physical barriers and mechanical systems, smoke control systems work to limit the spread of smoke through a building, ideally limiting the amount of damage the smoke can do to both the building and its occupants. The mechanical systems of smoke control include fans, dampers, doors, and shutters that all work together to isolate and contain the spread of smoke. These are generally installed in the initial construction of a building as well, and work in conjunction with sprinkler systems to prevent as much damage as possible to the structural integrity of a building. Fire alarm systems. Fire alarm systems are put in place in order to alert a building's occupants in the event of a fire. These are installed in every room of a building and are highly regulated by fire safety laws. Generally, these can be automatic or manual alarm systems. Automatic alarm systems can detect heat or smoke and emit a high-pitched alarm throughout the building. Manual alarms must be pulled by a building's occupants, and include simple instructions on how they can be used. Both types of alarms can emit a visual cue as well, seen as a bright flash.
Before diving in the sprinkler system, let us go through some basic information related to firefighting. The fire triangle. The fire triangle is a scientific principle that is important for all people to be aware of. Understanding how fires sustain themselves is essential background information in situations where you may have to use fire safety equipment. The fire triangle, or combustion triangle, is the three components needed to ignite and sustain a fire. The three ingredients of a fire triangle are heat, fuel, and oxygen. First, a source of heat is required for ignition to occur, and different materials have different flash points. Flash point is the lowest temperature at which the material ignites. Second, a fire cannot begin if there is no material to burn. Homes and businesses are full of flammable materials, such as paper, oil, wood, and fabrics. Any of these can serve as a fuel for a fire. Third, to sustain the combustion reaction, oxygen is needed, as it reacts with the burning fuel to release heat and CO2. Earth's atmosphere consists of 21% oxygen, so there is plenty available to trigger a fire if the other two components are present. Fire blankets and certain fire extinguishers remove the oxygen side of the triangle by removing it or displacing it, causing suffocation, and thereby ceasing the combustion reaction. So, here are some facts about the fire triangle that we should keep in mind. Normal air contains 21% oxygen. Fuel may also contain oxygen. Heat sources include the sun, hot surfaces, sparks, friction, and electrical energy. Fuel sources can be a solid, liquid, or gas. Firefighting systems are classified either manual or automatic. Manual firefighting systems includes extinguishers, fire cabinets, Siamese connection, and fire hydrants. These requires the physical intervention of manpower to fight the fire. Automatic system, as its name says, fights the fire automatically without the intervention of human being, and that's what a sprinkler system do. Here is a schematic diagram of the system components. Usually both systems exist in all buildings to form a competent firefighting system matching the NFPA standards. So, in any building, the system consists of three basic parts. A large store of water in tanks, either underground or on top of the building, called fire storage tanks. A specialized pumping system. This usually includes three types of pumps: jockey pump, electric pump, and diesel pump. You can refer to my video about fire pumping system for more info. A large network of pipes ending in either hydrants or sprinklers. Nearly all buildings require both of these systems. Sprinkler systems. When it comes to the sprinkler head itself, the four most common styles of sprinklers are the standard spray upright, standard spray pendant, sidewall sprinkler, concealed sprinkler head. Nearly all fire sprinklers are composed of the same components: a sealing assembly or plug that prevents water from escaping, a heat-sensitive element that allows water to flow at a given temperature, a deflector that distributes water effectively, and a frame. The sprinkler's temperature rating is the temperature at which the sprinkler will activate. Options range from 135 to 650 degrees Fahrenheit. These ratings can be identified by the color of the liquid inside the bulb in the case of glass bulb sprinklers. The selection is taken from NFPA 13 Table 7241 based on the hazard class for the structure that the fire sprinkler system is protecting. Upright sprinkler head. Upright fire sprinklers spray water upward to a concave deflector, like an umbrella, producing a dome-shaped spray pattern. Rather than descending through the ceiling, these sprinkler heads are usually mounted on pipes just below the ceiling. Upright sprinkler heads are efficient at dispersing water between obstructions. Thus, they are frequently used for rooms that are inaccessible, such as mechanical rooms and in warehouses and industrial spaces. They are also often applied in structures with open ceilings. The pendant fire sprinkler head. It is the most common type that you will see. Pendant sprinkler heads descend from the ceiling with a convex, circular, gap deflector plate on the bottom. When the sprinkler heads activate, they send a stream of water downward onto their deflectors, which then disperse the water widely, side to side, throughout the room in a conical pattern. Sidewall sprinkler heads protrude horizontally out of the wall parallel to the floor, rather than descending from the ceiling or mounted on a pipe pointing upward. Sidewall sprinklers are ideal for small spaces, such as hallways, spaces with obstructions, and where ceiling piping is not available. Concealed sprinkler head. This heat-sensitive plate detaches at temperatures roughly 20 degrees lower than the fire sprinkler head, allowing the concealed sprinkler's deflector to drop and the head to activate. Now we have covered the most common sprinkler head types. Let's go ahead and discover the fire sprinkler system types. There are 4 main types of systems: wet pipe system, dry pipe system, pre-action system, and deluge system. Wet pipe sprinkler systems. Here are the components of a wet sprinkler system. In addition to the water supply, piping, and sprinklers, these systems have backflow prevention device, control valve, main drain, fire department connection, water flow alarm. Wet pipe sprinkler systems always contain water in the riser and piping. As soon as a sprinkler head activates due to the heat of a fire, water is immediately discharged through the open head. Dry pipe fire sprinkler systems. Dry pipe systems are very similar to wet pipe systems with one major difference. The pipe is not constantly filled with water. Instead, the water is held behind a dry pipe valve, usually some distance away from where the sprinklers are located. Like a wet pipe system, when the temperature at the ceiling becomes hot enough, the glass bulb or fusible link of the sprinkler breaks. However, in this case, water isn't immediately available because the pipe is not water-filled. Instead, air is released from the now open sprinkler head. This creates a drop in pressure, causing the dry pipe valve to open and water to fill the system. Water will then flow from the open sprinkler head. Since there is a delay between sprinkler operation and water flow, the size of dry pipe systems is limited. The size limitation is intended to minimize the amount of time water delivery is delayed. A dry pipe system is a great option for unconditioned spaces, or locations where the temperature of the space cannot be guaranteed to be high enough to prevent water in the system from freezing. Pre-action system. A pre-action type sprinkler system employs the basic concept of a dry pipe system in that the sprinklers are closed and water is not normally contained within the pipes. One difference, however, is how water is admitted to the system. Water introduction into the system's piping is initiated by opening of a normally closed, mechanically latched valve known as a pre-action valve. Means of operating the pre-action valve depends on which of the 3 types of pre-action systems, non-interlock, single interlock or double interlock, is installed. Pre-action valve operation is dependent upon one or two of the following events occurring: sprinkler activation and detection device activation. A non-interlock system requires only one of either event to occur before water is admitted into the system. A single interlock system is activated only upon the event of detection device activation. However, in a double interlock system, the 2 separate events must happen before water is admitted into the system: sprinkler activation and detection device activation. Deluge systems are similar to pre-action systems in that they use another type of detection for operation. However, the biggest difference is that deluge systems use open sprinklers or nozzles. Instead of getting water flow from individual heads that have operated, once water fills the system, water will flow from every sprinkler head. Much like a pre-action system, a deluge valve will keep water from filling the system until the operation of another type of detection system, such as smoke detection. Once the detection system is activated, water not only fills the system, but flows from the open sprinklers or nozzles. An important consideration in the selection of the type of sprinkler system is the level of hazard being protected. If protecting an area of very high hazard, such as aircraft hangars, a deluge system may be the most suitable. Automatic sprinkler system design. The layout of fire sprinkler systems is usually one of the following. Tree sprinkler system. It is the normal design system, and it consists of main pipeline with branches on both left side and right side. Grid sprinkler system. A sprinkler system in which parallel cross mains are connected by multiple branch lines. Looped sprinkler system. A sprinkler system in which multiple cross mains are tied together so as to provide two paths for water to flow to an operating sprinkler and branch lines are not tied together. The maximum area of coverage per sprinkler head depends on hazard classification and sprinkler mounting orientation, that is, sidewall or overhead. Sprinkler head spacing. The table below shows sprinkler spacing requirements based on NFPA 13. For example, in a light hazard office area, the maximum coverage area per sprinkler head is 200 square feet, and the maximum design spacing between sprinklers is 15 feet. The maximum distance of sprinkler head from wall is half of the maximum distance between sprinkler heads. Minimum distance between sprinklers is typically 6 feet. Let us take an example: an office area of 90 by 60 feet. Assume we want to design a tree sprinkler system. Let us go ahead and lay out the piping system and sprinkler heads. Being a light hazard, the maximum spacing between sprinklers is 15 feet. The distance between sprinklers and walls is no more than half than the distance between sprinklers. The water demand for firefighting sprinkler systems shall be determined by either the pipe schedule method or the hydraulic calculation method. According to NFPA 13, pipe schedule system is defined as sprinkler system in which the pipe sizing is selected from a schedule that is determined by the occupancy classification and in which a given number of sprinklers are allowed to be supplied from specific sizes of pipe. Since our space is considered light hazard, and having no more than 2 sprinkler heads on each branch, then the size of all branches is 1 inch. For the main line, always start from the end. This portion is feeding 4 sprinkler heads, then its size should be 1.5 inches. This portion is feeding 8 sprinkler heads, then its size should be 2 inches. And all the rest are 2.5 inches because the number of sprinkler heads is more than 10 and less than 30. Now, what is the minimum water supply requirements for pipe schedule systems? The table below summarizes the minimum water flow rate, residual pressure, and duration of pipe schedule systems. Therefore, 500 GPM multiplied by 30 minutes means a minimum of 15,000 gallons water tank shall be constructed. A breakout of a floor control riser assembly. The following is a full arrangement for a combination standpipe sprinkler riser where high pressures necessitate a pressure-reducing valve at each level. While every element in this specific arrangement is certainly not a necessity on every project, here's some considerations that go into the requirements and considerations for a layout like this. Auxiliary drain valve. Permits faster draining of system, as opposed to only draining inspector's test valve. Check valve. Can help reduce false water flow alarms on floor where sprinklers have not activated. Drain pipe. Size, 3/4 inch for 2-inch system pipe, 1¼ inch for 2.5 to 3.5 system pipe, or 2 inch for 4-inch system pipe. Drain valve. Minimum size, 3/4 inch for 5 to 50 gallon system, 1 inch for above 50 gallon system. Drain riser. Discharge must be to outside or drain capable of handling the flow. Size must be at least 1 pipe size larger than the largest drain connection tying into it. Inspector's test. Must be accessible and must discharge outside or to a drain capable of handling flow. Must be downstream of water flow alarm. Pressure gauge. Required at each floor control valve. Pressure reducing valve. Provided to reduce the system pressure such that the working pressure will not exceed a standard 175 psi listed pressure of the sprinklers, piping, and fittings. PRVs can also be used to limit the system pressure to higher amounts when pressures are allowed to exceed 175 psi. Control valve for entire riser is required to permit isolating a riser without interrupting other systems. Size of minimum 4 inch, unless hydraulically calculated to permit smaller size. Sight glass enables easy verification of water flow for inspector's test. Floor control valve. Must be accessible, electrically supervised or locked, signage must be provided, and shall be tested annually. Water flow switch is used in wet sprinkler systems to detect the flow of water and to send an alarm signal.